In this video here, we're going to take a look at solving trigonometric equations. Now, as we mentioned in the introduction video to the t-formulae, we can use the t-formulae to solve trigonometric equations. So obviously that's what we want to do for this video here. And what I want to present to begin with here is a checklist to solving trigonometric equations using the t-formulae. So for the first step here then, we start by using the substitution of t equals tan of theta over 2 here. We then write any trigonometric function in terms of t. We then solve the resultant equation algebraically to find the values of t. And then finally here, we find the corresponding values of theta, which satisfy the original equation. So as you can see then, just 4 steps here, but these 4 steps are key to solving trigonometric equations using the t-formulae. So as we just mentioned then, by following the checklist above, we can solve trigonometric equations by using the t-formulae. So truthfully, this video shouldn't be too challenging here. I do think, overall, the t-formulae chapter is quite a nice, relaxing chapter for FP1. So in terms of an introduction here to solving trigonometric equations, that concludes everything that we need here. So all we're going to do now is take a look at one practice question here for solving trigonometric equations. So let's get started then with question 1 here. So as we can see then for question 1, right, this is split into 2 parts. Let's begin with part A here. Now for part A then it says using the substitution t equals tan of theta over 2, show that this equation here can be written as t squared minus 4t plus 3 is equal to 0. Now looking at this equation here, right, we could just use the R formulae, but obviously the way that this question is structured here, and as you can see by this quadratic equation here that's given in terms of t, we do need to use the t-formulae, right? So what trig functions do we have here? Well, we have sine theta, and we also have cosine theta. So let's just start then by stating the correct expressions here for sine theta and cos theta in terms of the t-formulae. So for sine theta here then, that's given as 2t all over 1 plus t squared, like so. And then for cos theta here, that is equal to, so I get 1 minus t squared all over 1 plus t squared. Okay, so in that case then, all I need to do here is replace sine theta and cos theta with their respective expressions here. Okay, so we get 2 lots of, so I get 2t all over 1 plus t squared. So 2t all over 1 plus t squared. Then we subtract cos theta here. So minus 1 minus t squared all over 1 plus t squared. Okay, like so. And this here then is equal to 2, right? That's equal to 2. Okay. So this left-hand side here, right, would be over a common denominator. So our common denominator here is 1 plus t squared. So we can just write this over a single fraction then, or over a single denominator. And expanding out here, I get 2 lots of 2t, so that's 4t. We then get minus 1 and minus t squared. So obviously just take care here with the signs. That gives me plus t squared. Okay, and that's all over then 1 plus t squared here. And that's all equal to 2. Okay. So the next thing that I'm going to do here then is multiply through by 1 plus t squared here. So on the right hand side then we're going to get 2 lots of 1 plus t squared. So I get 2 plus 2 t squared here. Okay. I've got 4t minus 1 plus t squared is equal to 2 plus 2t squared, as we've already mentioned, right? Just multiplying through by 1 plus t squared. So 2 plus 2t squared there, like so. And now if we take everything over to the right-hand side here then, what I get here, so I get 2t squared minus t squared, so that's t squared there. We're just going to subtract 4t off both sides here, so I get minus 4t. And then finally, we've got 2 plus 1 here. That would give me plus 3. And that's all equal to 0 here. And just notice then, it's exactly what we wanted here, right? So as required then, And that gives us the solution there to part A. Okay. Now for part B then, it says hence find all the solutions of this equation here, which is just the exact same as what we had in part A. For this interval here then, from 0 to 2 pi, giving your answers to 3 significant figures here. So we're solving for t then to begin with here. Okay, so let me just kind of box this off here a little bit, like so. So that was for part A, box it off there. And this here then is for part B. Okay, so as we've already said then, the first thing that we need to do here is solve for t. So solving this quadratic here, well, it looks pretty basic. And the first thing that we should check here is whether this factorizes. And the good news is then this does factorize. So factorizing here, what I get then is t minus 1 and t minus 3 here. Okay, and that's all equal to 0. Okay, now this gives me two values of t here. We get that t is equal to 1. And we also get that t is equal to 3. Now, at this point here, these are values of t, right? But we want values of theta. That's what we're solving for here, okay? So what I need to do now is use this substitution here. Okay, so using this substitution here, let's make a note of that here. So we're going to use t is equal to tan of theta over 2. And basically all we do here then is replace t with these two values here. Okay, and from there then, pretty basic, right? We can go on to solve for theta. So starting with when t equals 1 then, I get 1 is equal to tan of theta over 2, like so. So obviously we want to solve for theta here, right? We just take tan inverse of both sides, or arctan, whichever you prefer. In that case then, theta over 2 is equal to arctan of 1. So arctan of 1 here, like so. And in that case then, theta is equal to 2 lots of arctan of 1. Okay, so 2 arctan of 1, like so. Well, arctan of 1 is just pi over 4, right? If you times that by 2, I get 2 lots of pi over 4. 2 lots of pi over 4, giving us pi over 2. But the question does want us to give the answers here to 3 significant figures, right? So not in its exact form. So if I just quickly put this into my calculator here, right? To 3 significant figures here then. So 3 sig figs, what I get then is 1.57 here. Okay. But we're not done here. So we've done t equals 1 then. That's fine. We'll circle that. We're not done here because we also need to find the respective values of theta here, or the respective value of theta, I should say, when t equals 3. Okay, let's do that over here then. So when t equals 3, that was for, I can't speak anymore. When t equals 1, there we go. So when t equals 1, okay, we obtain this solution here for theta, and they're doing the same here then for when t equals 3. Okay, so we get 3 is equal to tan of theta over 2, like so. Again, just take arctan or tan inverse, whichever you prefer, both sides here. So in that case then, theta over 2 is equal to arctan of 3. And then finally here, in that case for theta here, just times through by 2. So theta is equal to 2 lots of arctan of 3, like so. So again, just put this into your calculator here. And again, just make sure that you give your answer to 3 significant figures here. And if you do that correctly, then what you should get here for theta is 2.50. Okay, you get 2.50. It looks a little bit messy. Let me try and rewrite that. 2.50 there. There we go. That's a little bit neater. Okay. So there we have it. So that gives us the solution there to part B and the solution to question 1. So let's just have a go then at the very last question here. So for question 2 then, again, just like the previous question here, this is split into 2 parts. So let's begin then with part A here. So for part A then, it says using the substitution t equals tan of theta over 2, show that this equation here can be written as 7t squared plus 8t plus 1 is equal to 0. So starting off then, what trig functions are we working with here for this equation? Well, as we can see then, right, we have cosine theta, and we also have sine theta. So in that case then, we're going to start here by stating the relevant results then for sine theta and cosine theta in terms of the t-formulae. So nice and straightforward here for sine theta, that's simply 2t all over 1 plus t squared. And now for cosine theta here, again, nice and straightforward here, we get 1 minus t squared all over 1 plus t squared. Okay, so in that case then, just replacing cos theta here with this result or this expression, and doing the same here then for sine theta and this result here. So what we get here then is 3 lots of cos theta. I get 3 lots of 1 minus t squared all over 1 plus t squared. And now we have minus 4 sine theta here, so minus 4 lots of, so we have 2t all over 1 plus t squared. So 2t all over 1 plus t squared. Okay, like so there. And this here then is equal to 4. Okay, like so. So this will be over a common denominator here of 1 plus t squared. And let's just expand these out as well, right? So I get 3 lots of 1 and 3 lots of minus t squared. I get 3 minus 3t squared. And we also have here then minus 4 lots of 2t, so that's minus 8t here. Like so. And as we've already said here then, this will be over a common denominator. Okay, so my common denominator here then is 1 plus t squared. So 1 plus t squared here, like so. And this here then is equal to 4. Now we want to get rid of this fraction here, right? So to get rid of the denominator here, we just times through by 1 plus t squared. So on the right-hand side, then we get 4 lots of 1 plus t squared. So I've got 3 minus 3t squared plus, not plus, minus 8t here. Like so. And then we get 4 lots of 1 plus t squared. We get 4 plus 4t squared. Like so. And then finally here, we want to make one side of this equation equal to 0. And the best way to do that is to take everything on the left-hand side here over to the right-hand side. And in doing so here then, what we obtain, so I get 4t squared plus 3t squared. So I get 7t squared here. So 7t squared. What else do we get here? So I've got minus 8t. So add that to both sides here. So I get plus 8t. And then finally here we got 4 minus 3. I get plus 1 there. Okay. And that's all equal to 0. And notice here then we get exactly what we want, right? We get 7t squared plus 8t plus 1 is equal to 0. So as required there. So as required. And that gives us the solution to part A. Okay. So we'll quickly box that off here then. Like so. And now we can have a go at part B. So for part B then, it says, hence find all the solutions of this equation here. Just notice it's the exact same as what we have in part A. In this given interval here then from 0 to 2 pi for theta, giving your answers to 3 significant figures here. So again, the first thing that we do here is we solve for t, right? So we've got this quadratic equation here. So as always, the first thing that we should do here is just check whether this factorizes. And again, the good news here is that this quadratic equation does factorize. So in that case then, what do I get here? So I get 7t plus 1. I also get t plus 1 here. And that is equal to 0. Okay. So from here, we get 2 solutions for t. So we get that t is equal, oops, my pen does not want to work today. Let's try again. So my pen and my tablet doesn't want to play ball. So I get t is equal to minus 1 over 7. There we go, a little bit better. And then for this solution here, we get that t is equal to minus 1. Okay. Now we're not done here because we're actually solving for theta as opposed to t here, right? So what I need to do now is use this substitution here of t equals tan of theta over 2 with these values of t here to go on and solve for theta. Okay. So let's start then with when t equals minus 1. Okay. So let's do this in different colors here just to highlight a little bit. I didn't do it for the previous question, but I'll do it for this one. So this is for when t equals minus 1. We'll do this one in red. So when t equals minus 1 here, I get tan of theta over 2 is equal to minus 1. Now we want to solve for theta, right? So I start by taking tan inverse or arctan of both sides here. So theta over 2 is equal to arctan of minus 1. Now, when I take arctan of minus 1 here, this would be negative, right? And I'll actually get minus pi over 4, but that's going to be outside this range here, this interval. Okay. So what I need to do then is add pi to that. Okay. So taking tan inverse of this here and adding pi to both sides, right? Adding pi to that as well. Okay, so when I add pi to that, it takes it into this interval here, which is what we want, right? So I'm going to get minus pi over 4. So minus pi over 4 plus pi. Okay. What I also need to do now is times through by 2, right? Because we want to solve for theta as opposed to theta over 2. In that case, then theta is going to be equal to 2 lots of this here. So 2 lots of minus pi over 4 plus pi. So all you need to do now is put this into your calculator here, right? Again, the answer wants to be 2 free significant figures here. If you put this into your calculator here and evaluate this correctly, what you should obtain then is theta is equal to 4.71 here. Okay, so you get 4.71 there. So that's for when t equals minus 1 here. So that one is done now. And now let's do the other solution here let's do it in blue here. We'll do this one in blue. So this is for when t is equal to minus 1 over 7. Okay. So when t equals minus 1 over 7 here, again, just following the same kind of pattern, we get tan of theta over 2 is equal to minus 1 over 7. Okay. Again, I need to take tan inverse here of both sides. But again, because this is negative here, when we take tan inverse of that, that will also be negative. Okay, so again, just following the same pattern here, we're going to add pi to the right-hand side here. Okay, the side that we take tan inverse of. We take tan inverse of both sides, right? But tan inverse of this side here. Okay, so what I get here then is theta over 2 is equal to, if I take tan inverse of this here, I get minus 0.141, so on and so on. Minus 0.141, so on and so on. We add pi to that to ensure that it's in the correct interval here, this interval from 0 to 2 pi. And then we need to times this by 2 here. Okay. So finally then, just times through by 2. So just do this all on your calculator, right? Don't try and do this off the top of your head. I'd be very impressed if you could, but don't do it off the top of your head. So theta then is going to be equal to, again, giving you answer to 3 significant figures here, we get 6.00 there. Okay. And there we have it. So that's for when t equals minus 1 over 7. And there we have it. So that gives us the solution to part B and the solution then to the very last question here, question 2. And that actually brings the end then of this video here on solving trigonometric equations.